So we're going to talk about factorization of whole numbers. So if we have 18, how do we factor 18? We could go 9 times 2 is 18. 6 times 3 is 18. So those are 6 and 3 are factors of 18. 9 and 2 are factors of 18. So if I say factor 18, you break it down into its factors. So 18 times 1, which is trivial. We could also go 18 equals 2 times 3 times 3. So when I say break down 18 into its factors, you can write it as 2 times 3 times 3. So let's look at each factor. 18 is 9 times 2. 2 and 9 are factors of 19. 2 is called a prime number because you cannot break it down any further. What are the factors of 2? One trivial factor is a 1. The only other factor is 2, right? Because 2 times 1 is 2. What about 9? Can you call this a prime number? 9 can be broken down into 3 times 3. So that's not a prime number because you can break it down further. 6 and 3 are factors. 3 is a prime number, but 6 is not a prime because 6 can be broken down further into 3 times 2. So this is a factorization of 18. This is another way of factoring 18. But look at this last one. Each number is a factor of 18. We have broken it down into factors. But what's important is each of these numbers is prime. So we've not only factored the number, we factored it into its prime factors. So it's called prime factorization of 18. So just remember, the word factoring means breaking it down into, so for example, 8 is 4 times 2. So we are factoring 8. But if I say break it down into its prime factors, then the only way of doing that is writing it as 2 times 2 times 2 because 4 is the same as 2 times 2. Now, if we have to factor numbers, we need to break it down. And if the numbers are large, sometimes we have to know where to begin. So for example, if 64 is the number, we know 64 is even. So we know that 2 goes into 64. So 2 goes how many times? 3 times into 6. Subtract, bring the 4 down. 2 times 2 is 4, leaving a remainder of 0. So a good start would be 32 times 2. The reason why we were able to start is because we looked at 64 and we said 64 is an even number. So therefore, 2 divides 64, and then that's how we broke it down, by dividing 64 by 2 to get 32 times 2. We can break 32 down further, and we can keep going until we get all prime numbers or prime factors. So how do we know that a number is divisible by 2? We know a number is divisible by 2 if it ends with the following digits: 0, 2, 4, 6, 8. If the last digit is either a 0 or a 2 or a 4 or a 6 or an 8, we know it's an even number and therefore divisible by 2, no matter how large the number is. 2,036,342. How do we know that 2 divides it? We just look at the last digit. If it's one of these numbers in the list, we know it is an even number, and an even number is divisible by 2. So you know that if you divide this number by 2, you're not going to get a remainder. Now the next one, how do we know that a number is divisible by 5? Think of the 5 times table. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. 5 times 6 is 30. Now we can keep going on, but notice the digits. The last digit in this number is a 5. The last digit in this number is a 0. Last digit 5. Last digit 0. Last digit 5. Last digit 0. A number that is divisible by 5 has either a 0 or a 5 in its ones place. So let's look at some examples. 2375 we know is divisible by 5 because all we care about is the last digit. If it's a 0 or a 5, we know that it's divisible by 5. What about 2,385,450? We know this number is divisible by 5 because the last digit is a 0. So if a whole number ends with a 5 or a 0, then we know that it's divisible by 5. How do we know divisibility by 10? If you know the 10 times table, 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. And that's how we get the list: 40, 50, 60, 70, 80, and so on. Notice the last digit of every single number. If a number ends with 0, then you know that it's divisible by 10. So if you have, for example, 2570 ends with a 0, so we know it's divisible by 10. We can write it as 257 times 10. 5,000 or 55,650. The last digit is 0, so we can write it as 5565 times 10. We know it is divisible by 10. Any number, whole number that ends with a 0 is divisible by 10. And similarly, we can think of 100 as well. So if we have 3500, we know is divisible by 100. Not only a 10, but by 100, because we can write this as 35 times 100. What if we have 725,000? It's divisible by a 10, it's divisible by 100, and it's also divisible by 1,000. 725 times 1,000. So the next one is divisibility by 3. Now this is something that I want you to pay careful attention. Now think of the 3 times table. Let me erase this. So we have 3 times 1 is 3. 3 times 2, 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6, 18. 3 times 7, 21. 3 times 8, 24. 3 times 9 is 27. And 3 times 10 is 30. 3 times 11 is 33. 3 times 12 is 36. Now let's look at all the products that have at least 2 digits. Now I take 12, add the 1 and the 2, I get a 3. Notice that the sum of the 2 digits is 3, so 3 divides 3. Now let's add 15 is 3 times 5. 1 plus 5 equals 6. 3 divides 6 because 3 times 2 is 6. Notice 18. 1 plus 8 is 9. Notice that 3 times 3 is 9. 3 divides 9. 2 plus 1 is 3. Again, 3 divides 3. 2 plus 4 is 6. 3 divides 6 because 3 times 2 is 6. 2 plus 7 is 9. 3 divides 9, so therefore 3 divides 27. So this is something you have to pay special attention to. A whole number is divisible by 3 if the sum of all the digits in the number are divisible by 3. So, for example, 153. So I'm going to take 153. I want to check if this number is divisible by 3, which means can I divide 153 by 3 and have a 0 remainder? So I go 1 plus 5 plus 3 is 9. 3 divides 9 because 3 times 3 is 9. So what is the conclusion that we make? 3 also divides the entire number, which is 153. Let's double check. Let's divide 153 by 3. 3 times 5 is 15. Subtract. Bring the 3 down. 3 times 1 is 3, leaving a remainder of 0, which means 153 is equal to 3 times 51. So this is the test for divisibility by 3. Add all the digits. Whatever number you get, check if that is divisible by 3, which means does 3 go into 9? Yes, it does, which means yes, 3 divides the number that you started with. Now, divisibility by 9 is very similar. So just let's look at the number 108. If we want to check if 9 divides 108, does 9 go into 108? Take the digits. 1 plus 0 plus 8 is 9. 9 divides 9, obviously. 9 times 1 is 9. So you know that 9 divides 108. 9 times 12 is 108 if you did the long division or if you remember the multiplication tables. Is 153 divisible by 9? 1 plus 5 plus 3 equals 9. Obviously 9 divides 9, so 9 divides 153. Let's check. Let's divide 153 by 9